Hello there and welcome to our Python set tutorial. Set and ordered collections of unique elements in Python, and they are useful for a variety of programming tasks. In this video, we would cover everything you need to know about Python sets, including how you can create them, add and remove, perform set operation like union or an intersection. So whether you're working on complex data structure or you're just looking for a simple way to manage unique elements, understanding Python sets is a unique and valuable skill for any Python developer. Welcome back. My name is Fumilayo from Bet Media, and welcome to our Python set tutorial. So we're using the Jupyter notebook as always, and this notebook will be available for download on the Bet Media website. So now, how do you create a Python set? There are two ways of creating a Python set. First, you can use the curly braces, or you can use the set function. I'll show you how to create using both ways. So using the curly braces, we have a list of fruits. Yeah. So this is a set, your element in a curly braces. And the thing about set is that set only allows for unique element. So we have two apples in the curly braces, but then if I print fruit and run this, you see we get only apple, banana, and orange because set only allows for unique elements unlike list. List can allow for multiple elements. The next way to create a set is by using the set function. Let me show you how you can do that. We have a set of numbers. Yes, so by using set, and then you have your numbers in a list. And when you print that, print numbers, and you run it, and you have your set. Similar to this, if you have the same element in your set and you run, you still get unique elements. So these are the two methods of creating sets in Python. Now we move to the next step, set operations. There are various operations that can be performed with sets. So first we'll start from union. We have a Venn diagram here that would show exactly what we're going to do. So union is that we're combining two sets to return a new set that would contain all the unique elements from both sets. So we have two sets and we want to join both of them together. That is what we have as union. So we have two circles representing the two sets, and everything is colored blue because we want to take every element of both sets, but they have to be unique. We can't have multiple sets. So I have my set one. Don't forget coily braces. Then I have one, two, and three. And then my set two, coily braces. And then I have three, four, and five. So this is my two sets. And then there are two methods of creating union of sets, and I'll show you both methods. First, you use the forward slash. I guess this is forward slash, and then what you have is like union set is then equals to a set one, and then a set two. So this is how you get the union of both sets. So then if I then print union set and run, you see we get union of both sets, the union of both sets. And then the next method is to use the union method. Let me show you how that works. We then have union set 2 equals to set 1 dot union, and then in brackets we have set 2. So then if I print union set 2 and then run this, we have our union. So these are the two methods to get your union of set, by using the symbol in between your set 1 and your set 2, and then print it, you get your union, or by using the union method. So your set 1 dot the union of your set 2, and when you print it, you get the union of your set. So everything in both sets, but they have to be unique. We can't have multiple elements in a set. The next set operation we'll be looking at is intersection. Intersection returns a new set that contains the common element present in both sets. So if you see our Venn diagram, we're trying to get the common element, which is this part here that is colored blue, from both sets. So it is the element that both sets has in common. So also there are two methods of doing this, and I will show you both methods. So we have our previous set that we're using and we'll continue to use throughout this tutorial. The first step is using the AND operator. So what we'll then have, since we're doing intersection set, is then equals to set 1 and set 2, and that's it. And then we'll print intersection set. And if we run this, we have 3. As you can see, 3 is what they share in common. The other method that we can use is the intersection method. So similar to what we have the union method, we also have the intersection method. So this is the intersection method. Our intersection set equals to set 1 dot intersection set 2. So then if we print intersection set and run this, we get the intersection. So you can use the AND operator or the intersection method to get the intersection, the common element present between two sets. The next part of our set operation is difference, or the difference method. Difference is that you want to return a new set that contains elements in the first set but not in the second set. So according to our Venn diagram, you see we want the element that is just belongs to A, the element that can be found in A but not in B. So just A. And then we have the two set that we're still using. And then there are two methods of doing this. The first method is using the minus operator. So then we have difference set is equal to set 1 minus set 2. And then we'll print that out, difference set. And when we run this, we see that 1 and 2 belongs exclusively to set 1. We can't find it in set 2. So we get that. Then the second method is using the difference method. So you see that we've had the union method, the intersection method, and now we have the difference method. And then when we print this difference set, we're using a similar way. So difference set equals to set 1 dot difference of set 2. So then we'll print the difference set. We get 1 and 2. So this is how you get the different elements, the difference between both sets that is exclusively belongs to A that is not shared with B. So just A set. So the next set operation that we're looking at is the symmetric difference method. Symmetric difference is you're trying to return a new set that contains element that's present in either of the sets but not in both. So elements that belongs to just A and to just B. So not the elements that they both share in common. And there are two methods of doing this. We can use this symbol or use the symmetric difference method to get that. So we still have the same set. We're using our set 1 and our set 2. So first using that operator, the same way symmetric difference set equals to set 1 and then our symmetric difference operator set 2. So if we print it, we should get 1, 2, 4, 5 because those are the elements that both sets have uniquely to them. So if we run this, see we get that 1, 2, 4, 5. And then the next method is the using the symmetric difference method. So if we have that, we have the union, the intersection, the difference method, and also the symmetric difference method. And then when we run it, we have 1, 2, 4, 5. So these are the both methods of getting the symmetric difference of two sets. Returning a new set that contains element that is present in either of the sets, but not in both. Next, we're looking at subsets. We're trying to check if all the elements of one set is present in another set. So, for example, now we have three sets that we're using to check. We have 1, 2, 3, and then for set one, we have 1, 2, 3, 4. So, if something like this, you want to check if everything you have in set 2 is also present in set 1, or if anything you have in set 2 is present in set 3. And then there are also two different methods of doing this. Let me show you. You can use the less than or equal to sign, and you can also use the subset method. It's subset method. So using the less than or equal to sign, a subset that is set to a subset of set 1. So then if we print this subset and then you run this, we get true because truly set 2 is a subset of set 1. But if I want to check for something that is not a subset, copy and paste this here. So now I want to check if set 3 is a subset of set 1. And we know it is not. So we should get false because it is not a subset. So what if you want to use the is a subset method? We've used the less than not equal to sign. And then if you want to use the subset method, we have is set to a subset of set 1. And we know it is a subset, so it should return true. So these are the two methods to check if a smaller set contains all the elements, or if a bigger set contains all the elements of a smaller set. That is, if all the elements of one set can be found in another set. So we're trying to find if it is a subset of a set. And you can use the less than equal to operator, or you can use the is subset method. So the final thing we'll be looking at in this tutorial is disjoint. Disjoint operation is you're trying to check if a set have no common element, that they share absolutely nothing in common. And what you use is the disjoint method. So now I want to check if we have disjoint between our sets. So we have three sets here 1, 2, 3, 4, and 4, 5, 6, and 3, 4, 5. So you can see that set 1 and set 2 have nothing in common. They have nothing in common. So if I want to check if they're disjoint, I have a set 1, a disjoint of set 2. And then when I print this, I should get true because they have absolutely nothing in common. So when I run this, it's true because they don't have anything in common. Then if I want to check for set 2 and set 3, let me run, copy this, 2 and 3. And then when I run this, we get false because really they share things in common. So there you have it on our set theory or set operation. We first started with creating a set, and then we went through some set operation, union, intersection, difference, symmetric difference, subset, and then finally disjoint. So that's it for you guys. Thank you for watching, and do not forget to check out our next video where we'll talk on Python dictionaries. Bye for now.